So welcome back to this webinar series, the VELUX Project Development Guide series. This is the 5th webinar in a row of 6. So there's only one left after today. I'm here with Nicholas Roy. Welcome to the webinar.
Thank you.
And we're going to be talking about daylight simulation. So in general, we've been talking a lot about modeling and BIM and quantities and details, and today it's about securing that the house actually performs as we want and designing for that performance. So I think we'll just jump right into it. So mastering daylight simulation. And the agenda of today is trying to get a view on what Daylight Visualizer is and why it makes sense to simulate daylight and how all the technical stuff works behind it. And then we're going to jump back to the BIM part and find our project and change what needed to be changed to prepare the project for an export for the simulation tool. And then we're jumping to the daylight simulation, and we'll see. Wanted to call it a live demonstration, but it's not really live because there's some long rendering processes that have been speeded up. So it's almost a live click-by-click demonstration of how we do the daylight simulation. And after that, we will just have a short view on how that can be shown on. You call it a gimmick, but in BIMX we can show the daylight simulation inside the BIM model, and it might make sense, and it might be a gimmick, but that might also make sense.
You were not supposed to say that.
and then in the end we'll answer questions, and hopefully today we'll have time for a lot of questions. So please, if you have questions, write them directly in the thread, and you might get an answer written during the webinar, and we might have time to answer live in the end. If there's any unanswered questions, we'll of course make sure that there will be an answer later on the event page. So this whole webinar series is called the Project Development Guide, and it's a longer process where we have done a full project workflow from the first sketches to the end of the detailing phase. And everything is done using BIM. We have tried to get the most use of the method as possible, which also this daylight simulation part is a big part of. The whole documentation is on the website, so go to velux.com, Project Development Guide, and you can see the earlier webinars again perhaps, and you can find a download link for the complete material. That's the Archicad files, IFC files, DWGs, and the PDF for the drawing material. And we also have a link for the BIMX, which is this interactive BIM viewer that works on Mac and Windows. It actually also works in the browser, but not very fast and intuitive. So the best experience is definitely on an iPad or tablet or smartphone, where you kind of get really close to the model. The project we've been inspired by is called Home for Life. It's a building close to Aarhus. It's been done by art architects and Espensen consultant engineers. It was built in 2009, and it's the perfect project to show all these decisions that are going on in the design process to make a building that's not only functional due to rooms and views, but also into indoor climate and limiting the amount of energy that is needed to operate a building like this. So we have had a lot of learnings, and you might want to go back to some of the earlier webinars to see perhaps how the LCA was done to make sure that this is also a sustainable project. So today, mastering daylight simulation, and we'll start by talking about the technique in general, and then we'll move slowly towards the VELUX Daylight Visualizer application that does this. And of course, that's a free software that's downloaded on the VELUX website. And I haven't really figured out if it's really easy to use or if it's also a little bit complex. So like BIM, it's not something that's just 2 clicks and then everything works. But I think it's actually rather simple to do a really complex evaluation of your project. So Nicholas, why are daylight tools so important?
Well, let's look at it. Thanks, Thomas, for a really good introduction. So daylight tools are important for a number of reasons. They help us to create more sustainable and healthy buildings, meeting the needs of the occupants for contact to the outdoors and in terms of getting the right amount of light at the right time of day. It's very much in the hands of designers to create buildings with indoor conditions that allow us to strive. It also helps us to prepare the next generation of professionals in education. For example, Daylight Visualizer, as a lot of the users are from universities and schools of architecture and engineering. And then it helps us to enforce better requirements for daylight in buildings, moving away from simple rules of thumbs to much more accurate indicators, performance metrics that are sensitive to the placement, the size of window, and also the context outside the building, whether or not daylight is available in the first place. So these are some of the benefits of using simulation tools. And just to give 2 examples here of how it can benefit also real life projects. So we have this kindergarten here. Also built around 2010-11, and the architect was having the original design, and it's quite generous in daylight, as you can see the image on the left side. But there was some rooms like the little gymnasium where only more or less 2% daylight factor would be available. So there was some areas that through doing that simulation you could identify to improve the buildings. And then they just not adding any window, but just placing around, what was available, taking away a little bit from the corridors to bring to these key spaces. And that's something the tools allows to refine that puzzle that you could only get so far with the intuition. And then this project is another one where just spending a day or half a day in the tool, you are able to show how you can really improve the daylight conditions. For example, in this school that would have been relying totally on electrical lighting, and then they went ahead and did the project using a lot more daylight.
So with traditional tools, or not tools, but rules of thumb, where you have a square meter count for the window area, and you look at it in proportional to this area of the floor. Mm-hmm. How much more accurate this is, especially when you have skylights? I imagine there's a big difference between having facade windows and having skylights when you have these simple rules.
Yes, very much. For example, we make some simple studies where we say if we use exactly the same size of window in the facade or on the roof or on the slope roof, or compare it to a dormer window, and then you can see which situation provides more daylight. And then the more you see the sky, the more you see the light source, the more daylight you can bring in inside the rooms. And that's why it's important to, of course, take the external obstruction. So if you are in a semi-urban or even an urban context, then the daylight is not available to the same level as if you are in a rural situation. So all these things are perfectly taken into account in the tools.
Yeah, and something you don't get from just having to compare 2 areas to each other.
No.
Yeah, exactly.
Then Daylight Visualizer is a tool that is quite powerful. It's easy to use, and then it's accurate. The technique used for simulation is bidirectional ray tracing with photo mapping. It allows to do advanced simulation like light transport through a light pipe where sunlight is bouncing many times before it actually reaches the interior of the room. That's the kind of the most advanced simulation that you may ever need to do in daylighting. And then the tool make that very simple compared to what is otherwise possible for this very complex situation. Then you visualize the results into force color. There's different kind of force color in the tool. They all communicate the same information. It's just a different mapping. Then we make the interface. We try to simplify the process with the progress bar at the top, dividing the steps into very clear, let's call it bucket. And then we have 3 views, a plan view, a 3D preview, and a section view. And the input and parameter for each of the steps at the bottom, and then some simple instructions on the right. The tool can be used for beginners and advanced users, so you can very quickly create a simple 3D model in the tool, or you can import a model from simple schematic model, early design, to really complex, large-scale buildings through the 3D importer. And there we support a range of file format that makes it so that you can export from Revit, Archicad, and pretty much all the 3D package out there used by professional. I recommend OBJ, but SketchUp is also working really well. That's what we will use today in our demonstration. Then DWG, DXF, and IFC.
And IFC doesn't really make that much sense because you don't need the information of the BIM project. You just need the geometry and the surfaces. So there's no real benefit of getting IFC compared to just a 3D format like SketchUp or OBJ.
No, I don't think there's any benefits because in daylighting what you need is geometry and then the reflectance and transmittance of surfaces. You don't need to carry so much more information. But we support IFC because maybe it helps with the integrating with the various workflows that professionals are using and the way they exchange model. Yeah. The daylight analysis feature, we do support it's a little bit more looking back the single point in time, 15 CIE sky models. You can simulate luminance or illuminance any time of day, time of year. Then you have the daylight factor, which is not a time or orientation or location sensitive factor. And then more recently we have released annual climate-based simulations, can make daylight autonomy, useful daylight illuminance. We'll go over that a bit more detail in the demo. But there you take into account all the daylight hours during the year, and it's based on the actual climatic data for your location, and things get a lot more precise and rich in your analysis. Then we make it easy to document the results through a report function. Illuminance. So illuminance is the light falling on surfaces, and luminance is the light emitted from surfaces. Very often with the lux meter and in lighting, we've been measuring how much light falls on the work surface so that you can actually perform a task there. So that's based on illuminance. And then what we see, and also when you take a picture and so on, that's based on the luminance, so the light that's emitted from surfaces or light sources, like the sky and the sun.
And there's a difference between doing this kind of simulation and then doing a render, a normal visualization, because like taking a photo, you can have the darkest room seem well lit. And the same thing you can do when you use the built-in visualizing mechanisms in Archicad or in other render engines. So even though it looks like there's tons of light, there might not be that in real life. So we need tools like this to make this calculation.
Very much. In a tool like Daylight Visualizer and also the other tool, you can also expose the rendered image to make it look brighter or darker, but it will not change the calculated value that you see in the false color. So that's really where the information about the lighting quantities lie. Then we have those 15 CI sky, sunny sky, overcast sky. Here as an example is a totally different, of course, distribution and quantities of light in the space. You can also make quite photorealistic rendering. What I like in this one is especially how the highlight of the soft diffuse daylight and the shadows in the space matches really well between the rendering on the left and the picture of the final project on the right. Then daylight factor here on the left, which is seen on a plan view. You can use either ISO contour or false color to see the different levels. And then the annual climate-based simulation also seen on a plan view. So the two look quite similar, but the annual climate-based simulation actually reports the occurrence of your desired light level based on 4,400 hours for the year, whereas the daylight factor is a simple one-time measurement under a diffuse overcast sky condition. In the European standard, we have recommendations where we should achieve a target illuminance of a certain level for 50% of daylight hours during the year and 50% of the work plane area. So that means that when you use daylight autonomy as the indicator, that you would like to achieve a median value of at least 50% for your target. The median value will ensure that you have 50% of the work plane above that desired threshold. The threshold for illuminance is 300 lux, which is very often the one that you will find put in regulation here in Denmark to meet that number. But then they also suggested some higher level to achieve, either 500 lux or 750 lux. And then to allow for a wider range, say, of software and also, workflows to be able to work with the standard, they have derived, based on climatic data, some daylight factor target to meet that should be the equivalent of 200, 500, 750 lux. These, of course, don't match one another perfectly. Climate where there's a lot of sun will, of course, have a bigger difference from these daylight factor targets because daylight factor sort of omits the sun in the orientation. But it's kind of like, what the framework that they provided. And those two methods are described, but then in Denmark, again, they are mostly enforcing method 1.
And what kind of buildings need to fall within these thresholds? Is this all new builds, or is it only offices?
That is depending on the regulation in each country.
Okay.
What they did, a standard comes with a set of recommendation, a framework, a method, and then building regulation needs to put that in practice. Yeah.
Perfect.
So usually it's meant to be for the room which are commonly used during daytime with good occupancy.
Great. So that's the technical background, and before we do a real simulation, we need to either model inside Daylight Visualizer or import a model. And of course, we want to import our BIM project from the project development guide. And it's not just making an export, it's not just save as, but we need to structure the project so it's easily understood by the simulation software. And that means we have to remap all surfaces and name them carefully so it's easy to see what is what. We need to edit the surroundings, and then we have to put a plane in each room, which will be the measuring plane for the simulation. And when that's done, we're gonna export as an SKP file, so that's a SketchUp file. So here we jumped right into our project in Archicad. And we need to map all the surfaces for walls and ceilings and roofs and windows and surroundings. And we do that by using the graphic override system inside Archicad. So we've done a lot of rules for different building objects. So this is walls, columns, beams, and railings. And we've done a surface called DVIS walls that are mapped to that. The same with the surrounding boundary wall. And every building type in the model has its own material that is mapped by this. And when I say every building component, it's not really true because windows are not done by the graphic override. So we have to choose the windows and go into the settings. And this is VELUX windows. So the settings might differ a little bit from manufacturer to manufacturer in the BIM objects. But here's the outside frame material, and we have a surface for that. And then the sash and also the glazing. So one material for each. And we've done all of them white, but you could also have different colors so it's easy to see in the model if everything is mapped correctly. And since this is just an override, it will not damage the models, so we can still continue working in it and then just use these overrides when we need to export for Daylight Visualizer. We didn't cover the skylights yet, and those are, of course, very, very important. So they are mapped with the model view options, and VELUX has made a special pane in the model view options settings where we can set a material for glazing and then also for others, which will be the frames and fittings. So now all the materials of the building is correct. Then we need to make a plane for the calculation or the simulation. And we do that by using the morph tool, just to do a 2D plane inside each room. So here we just snap to the corners of the room, but since the simulation should only be done half a meter away from the walls, we just offset the whole plane with a distance of 500 millimeters. And then we also must make sure that it's elevated 85 centimeters from the floor, so we have this plane in the right height. And the last thing that is important is that we have the right surface on them, so it's easy to recognize each room from each other when they're imported into the Daylight Visualizer. So here we have all the different rooms, one morph at a time. Room 1 and bathroom. Very structured. And that's, of course, always important with BIM, that all the information is structured perfectly inside the model. In this project, we have a really large terrain model with the surrounding buildings also, and that might be a little bit too much for the simulation. So we're going to do a 3D cutaway from the building side just to make it smaller and closer to the project. We'll just cut from each side. It's not that important how big a plot you make, but you need to have some kind of terrain outside and perhaps a few buildings surrounding. But the smaller, the easier. Then we finalize. We just save this cutting box. And then I want to make a wall surrounding my whole plot. And the reason is to make sure that we take into account low-angled sunshine that might hit other buildings that are far away from our building. So using the beam tool, we just add the structure. The reason for using the beam tool is it's really easy to snap around the terrain. If you use the wall tool, it would have a horizontal wall as default. So beam tool is really easy. So we can connect here. Then we just want to make sure that this is not a traditional beam, but it's a 3-meter high wall. So we just select it, go to the settings, make sure the reference axis is in the bottom, and then it's 3,000 millimeters high. And because we already did the graphic overrides, it will have the right material of the bounding wall. So now our project is perfect for export. So we do a save as from the 3D view and choose a great name called final. And then also the file type, which is SKP, the SketchUp file type, and then just press save. So it's a few clicks, but when this is set up, it's saved. So it's really easy to make sure that if we want to update simulation, the daylight simulation at a later time, we can do a new export, almost standard. And actually, if we wanted to, we could save this as a publishing set also. So with one click, it would automate the whole exporting process. So now we're ready. Are you ready, Nicholas?
Yeah. Thanks for the demo. Well done. So now we'll look into importing that model in Daylight Visualizer. So when we start the application, we click Import Model, find that SketchUp model. It takes a few seconds and the model will load. At the top, we have the progress bar. The different steps we'll need to go through for our analysis. We have the plan view, we can zoom in, 3D view, can rotate and zoom, section view. We have the options for the different steps at the bottom. In the first one, we can choose unit, apply scale factor. Then we have the simple instructions. We have a couple of tools in the viewport. First of all, you can adjust the position of these blue lines for what is the content of the section view and the plan view. Then in the top corner of the viewport, you have the tools like measure icon, fitting the model in the view, zooming, and panning. You can also use the mouse wheel and 2 mouse buttons for panning. So now that we have, now that we've gone through the interface.
It's really simple and intuitive.
Yeah. Now what I want to do is I want to take a measurement to make sure that the scale of the model is correct. And that's very important because you do tell the software to measure every, so many centimeters for the sensor points. So if your model is in kilometers instead of meters, you'd have, insane amount of points for calculation. So it's very important.
You will find out eventually when you're waiting for the calculation to finish.
Yeah, you'd wait a long time. So now we move to the Surface tab, and here we have the elements. So that's all the models that was exported through the Archicad model via SketchUp. And we can recognize DViz, sealing, and so on. And then we have the material type in DViz, and then some surfaces predefined for those. So the exterior ground that will always be present in your model, that's basically half of the hemisphere, the bottom half of the hemisphere of the lighting environment. That should be set to 20%, and that's a default value for it. Then we'll go to DViz sealing. So here we should set a value of 70%. For doing these kind of, reflectance factor, you should always use a plastic material. When you want to do daylight analysis, it's not the color or the texture, it's really the reflectance that's important. That allows you to set it very quickly. The context we also need to set to 20% as per the regulation in Denmark. Same thing for surrounding grounds and buildings and vegetation. Yeah. So here, like if you use the glass surface material, it assumes only one layer of polygon. So like, no thickness, just a face. Then if you use a solid glass, then it assumes 2. And then it's very important because when the ray tracing goes through the material, then it applies a transmittance factor either to just 1 layer or to 2. And that can change the total amount of light that will be transmitted by your glazing. The interior glazing we need to set to 90% reflectance because it's just, not, no energy coating or anything, just single layers. So it's about 90% reflectance. Then the roof glazing, we need to use also glass solid and set it here to 68%. The roof window frame was set like the ceiling at 70% reflectance. And the walls was set at 50%. So here I'm just following what is recommended in the Danish regulation for daylight analysis. But these are also part of the ranges recommended by the European standard. Then next we have those zones, and this is very important. So all these, we created for each room in Archicad that we tag as a zone, because then this geometry does not block the daylight from going to the floor and distributing in the space. It just tells the program, this is where I want you to very precisely measure the daylight. After that, we have all the remaining material that were not edited in Archicad, either because they are part of the inside the walls or just a very small piece of geometry. So for these, you can just keep the default value, that was exported through the SketchUp value, which is average, reflectance based on these object properties. Next, we will set the location, and here you can choose from a drop-down all the capitals of the world or input custom properties. But in our case, we will just use a weather file. So here I can go to some weather file, download it. I'll choose Aarhus because the house is located very nearby that measurement location. Now I set the orientation. I'm offset by 15 degrees here as to how the model is sitting in Daylight Visualizer. And then I need to set the plan view, because here I would like to make both a plan view rendering and also the zones. You actually have the choice. You can render only the zones or only the plan view. If you just want to make your calculation and want to save time, then I'll say just render the zone, because you save about half your simulation time. But if you want to do like a nice output and really see how the daylight goes from the window over the area of the house, then the plan view is a lot better, provides a lot more understanding for someone who's not familiar with the exact position of the zones. And here what we do is we set the area, so where we would like this output to focus on. It will still take into account all the external obstruction and everything that's in the model, but the tool will actually calculate how's the daylight at these points that now we've. So it creates a better output and also save you some time again on calculating less points. And then we go to the render steps, and here you have different kind of, so still images where we'll find the daylight factor, and we will actually start by doing that simulation. So when you choose daylight factor, time of day, time of year is blocked out because it's not something that will influence the results. Then we do it under overcast sky. You could also choose uniform sky in Daylight Visualizer, but the common practice is to do it for overcast. And we have a resolution for the images, but the most important parameter for speed and quality is the render quality and then the sensor spacing. And they both have quite a big impact on simulation time. So when you want to make a simulation, early design and inform your project, then you can use much higher centimeter spacing for your sensor, maybe 30 to 60. But when you need to make a final verified calculation, say for meeting the European standard, then they recommend that in smaller room you need to have 10 centimeter spacing. So that's the plan view output. And here in the output viewer, we have the camera and the zones that we can switch from since we computed both. We can clear some mark values. You can add, save the image. It's the first time.
And how long time did it take to generate that image?
Daylight factor is pretty quick. Here you could change the legend values. So here it gives you, if you put 0 to 10, gives you just one increment very cleanly. You can choose different color mapping. We support 4. Like I say, this doesn't change the values. It just change how you like to visualize those. ISO contour. And ISO contour, you can change the exposure to make the calculated illuminance value brighter or darker depending on how bright was the simulation. But as you can see, changing the exposure makes no difference at all to the false color values. Then you can right click to put some pixel mark. You can hold left click button, drag an area, leave the mouse over and you get a model. giving you some information about the light performance in this area. And then we'll go to the zone. And here we have actually the very precise area that we wanted to calculate. And if you leave the mouse over there, you will get some basic statistics for it. Now we also have that little carousel where we can choose the different zones and look at the results. But we will actually get a lot more information when we export the report to HTML file. For doing so, you should always use a separate folder because it will write the name of the zone as your images, and then you could overwrite some simulation. So individual folder each time. Then when you've saved it, it will open in your browser, and here you can choose a country, the reporting you would like to have. So yeah, I choose European Standard and the percentile, and I'm gonna go to the kitchen room. There we can see the basic statistics that was actually shown in the model, but then we have the European Standard, and it tells me whether or not I pass a minimum requirement to meet 100 lux, 95% of the space, 200 lux, and so on. Yeah, it's going quick. Then you can take a few notes and save your report to a PDF. Then we'll do the annual simulation. And this one actually took more time to compute. It can take like from, I mean, for a simple room, again, it's how many points you have, but it can, for a building like this with the very low option and a large spacing, I could get done, you know, early simulation to inform me, is it correct, on the right path, and maybe half an hour. But then if I say I want 10 centimeters spacing instead of 60 or something like that, I have 36 times more simulation time, and then I'll take 4 or 5 hours. So it's something you can render overnight for your final, you know, very accurate, verified calculations.
And it uses the CPUs of the computer, so the faster computer, the faster simulation.
The more CPU you have, the faster it will go, since Daylight Visualizer works across or parallel across all your available CPUs. Okay, so Daylight Autonomy is ready. So now we have a target. So it's the occurrence that we see on the left with the legend from 0 to 100. Now if I say I want to update to 500 lux as the target, it recomputes and then show me the new map. Now what we see is if we want 500 lux as the target instead of 300, then there's a slightly lower occurrence of these levels. I can show you that when you make, you know, daylight annual simulation, there's actually way less contrast in the values, and as such, I find that false color is really the right mode to look at the data, because it's again, it's not a single point in time; it's all these occurrences compiled together. It's quite different than single point in time daylight factor or illuminance and so on. Another thing we can do is to change the range of hours. So sometimes you might do a building that has a very specific occupancy schedule and you want to see how is the performance when the building is used. So here you can select a specific range of hours, and usually to use less, you know, it will show a slightly better results because you take away the very early and the very late hours where daylight is lower. So now I went back to all daylight hours and I will export the report. Oh no, first of all I'll save the plan view for daylight autonomy on the ground floor. 500 lux.
And that's the one we're going to use later on showing
no, I think it will be the 300 I sent. So now because it's not exactly the same information, so now I'm like, you'd better here save more iteration like 750, 300, 500, and then you know you have them saved. So that's what I do.
Okay.
Yeah. Perfect. But since the room on the upper floor, they have slightly less amount of daylight, then I use the 300 lux as the old reporting for the project. And again, you can do, you know, right-click, pixel value, drag areas, and then go to the zone, get the model, show you some of the data. So exactly the same as in, you know, the daylight factor output viewer, but here you can choose between the different daylight metrics, and the target works slightly different than, you know, it did for daylight factor, just setting the legend. Then we'll save to HTML. Will the space bar be a pause button?
I'm not sure.
Okay. And here I'll choose percentiles, fractions of work plane, and European standard as the reporting. And here the information, about the target is no longer country per country like daylight factor, because here the target is the same. It's just to have the weather file. So here we can see again the default, you know, statistics that will always be there. Then we added the European standard. We see that this space meets the requirement for 300 lux over 50% of the space, and also 100 lux over 95% of the space, which is slightly less known maybe. And then we have the fractions of work plane and the percentiles. So sometimes with DGNB or other rating systems, it's not just about the median, but, you know, how much fraction of the space meets a certain level. So here with the percentile and fraction of the work planes, you actually have all that information. And if you look at the, for example, the median and the percentile, so that's exactly the same median, you know, 55.76. But then if you look at how much of the work plane meet, you know, more than 50%, 300 lux, then it's actually 91% of the work plane that meets that. So yeah, it communicates a different information. And if you look like at the 10 percentile, you see it's just at the 10 percentile that you go below 50. So that kind of tells you, yeah, there's 90% of the space that, you know, meets that. So here you have a lot of data that you can use to evaluate either the European standard, but also other daylight availability requirements that you might find in other rating systems.
So we've been looking at, now it's paused. So we've been looking at these south pointing skylights. And in the summertime, they will generate a lot of heat, so there's outside shutters. Are those shutters taken into account, or do you just do the daylight simulation as they're open all time?
By default here, you don't have shading applied. Then you would need to, what you could do is to take a workflow where you have a situation A without shading, and then another model with shading. And then one thing we haven't discussed in detail is that when you save to the HTML report, you also have an export button there where you could export hourly luminance data. So all the hours at each sensor point, you can actually get the raw data. But I would say it's you would need to be quite good at making a script to make it easy to then say which period of the year you want to see with the sun on. Otherwise, what I would do is maybe just do a couple of instants, you know, to try and see how is the light, you know, at these different,
Because with this exact project, there's some south-facing skylights that will probably shut off in the summer period, but there's also some north-facing that will give daylight when the shutters to the south are on, and the top of the walls are glazed, so you can bring that north light all the way through the building. So it's really a clever building, so it would make sense to kind of dig down into that study and see how that performs.
Yeah. All right, we move on. And here that's our kitchen that was actually passing all the levels, and the living room. So you can have like quite different level of performance. At 300, like the kitchen in the living room meets 100% of the value, but if you go to 500, then the kitchen has a high performance, 750, much higher. So that's why you find different information, coming for different target levels.
So here there's more light in the kitchen, which is good, and perhaps a little bit less light in the living room, which might also be good.
There's plenty of light in both. Basically, these are the very, very well daylit space in the house. Yeah. And 90% of the space meeting 300 lux is extremely generous. Cool. And then the support and learning materials. So we have a YouTube channel where you can see a lot of tutorials for our BIM and also simulation tool, Daylight Visualizer.
And this is very important because the VELUX Daylight Visualizer is a free tool that you just download. It works for Mac and Windows. Everybody can use it, but of course it needs a little bit of understanding to use.
Yeah, I would say, one of the important things is to get comfortable to exchange the model, export, import from a software. And of course, the accurate link between the geometry and the material properties. I mean, this is what matters in daylight simulations.
And when you did the mapping, that you were changing the reflectance, so the ceiling should have 70% and the walls should have 50% reflection. Yeah. Does that also, are there some materials here that tells me what to map?
Well, I mean, in the Danish regulation, every building should have those values. So then you evaluate, not based on what somebody puts the paint for a duration of 5 years, somebody puts a different color, right? So then every building gets evaluated kind of on the same basis as to the interior reflectances. There's some pros and cons to it, yeah. But I believe I think so. So here's a YouTube channel with our tutorials, learn how to use the tool. Here's a link where you can find EPW maps for weather file across the entire world. It's entirely free. Then we have this database, spectraldb.com. So here we have a bunch, maybe 1,000 of real world material that were all measured with scientific equipment. It's called a spectrophotometer. So here we have the exact, what is the reflectance, what is the specularity, roughness, and so on. You even have the material description if you was working with radiance. But basically, if you look at the radiance definition, then the first 3 numbers are the RGB reflectance values. So you could just bring that to Daylight Visualizer. You could also then use the specularity and roughness value for that matter as well, which is the next 2 numbers. So that's very valuable here because yes, you can learn that, what is, the concrete or wood or white wall. And then you find out that white is not 100%, on the RGB slider. It's more about 85% value of it. You can also download some nice texture if you want to do more like play with photorealistic rendering from ambientcg.com. And then for support, you contact us at daylightvisualizer.velux.com, and then I can give a lot better support if we have the VS file and quite clear description of the issue. Yeah.
Perfect.
Thank you very much.
So there's help if I have a project that I need to understand better.
Yeah.
So bringing this back to the BIM project, it's really easy to add these reports to the drawing material inside Archicad using the different layouts, especially these simulated daylight plans. And I love that it's not just the zones, but it's the entire plan that is simulated. So what we do is we add it to a layout, and we do that exactly on top of a current plan, so we can map it to the right place in the model. And then in BIMX, we can show the layout on top of the model and actually also lift the calculation or the simulation to the right height, the 85 centimeters above the floor. So here I'm inside BIMX, the app on my iPhone. I go to my daylight plan and I open that in a 3D view. So the whole layout is put on top of the floor plan in the 3D model. So I can see with the color map and the false color and the legend outside the house, how much light there is in each part of the building. And this is kind of more easy to understand. It's a little bit more intuitive to to see, instead of just an abstract plan, to see it directly in a 3D view. So what I want to do is I want to just go down to something that could be eye level, and then I want to raise the layout to something that's close to 85 centimeters above the floor. So the mapping of the simulation fits with the geometry of the building. So I'll just walk into my bedroom here and see how the light enters through the windows. And of course I can always jump back to my layout, perhaps go to another story or to something else with the simulation. So that's what we covered today. So if we want to just look back, it makes very much sense to use daylight as a part of your design performance, and for that to work you need to have a 3D model early on and then do several exports to an application like the VELUX Daylight Visualizer to figure out where to place windows. And the more simulations you do, the better decisions you will also do. And this is a very accurate way of both measuring, simulating, and also document the daylight. So you can see where to place windows and perhaps how to use skylights more instead of facade windows. It's easy to communicate this when you have the documentation. Perhaps especially with the BIMX tool, everybody can understand where there's light, but also looking at these different scenarios of 50% light or 300 lux to see what works and what doesn't. If you have these workflows built in, if you save the model, if you use a clever way of graphic overrides and model view options in Archicad, you can save all that in a view and in a publishing set, so it's only one click to export the model for import in other tools. Of course, like everything else, when you use standards, it's easier to collaborate, it's easier for others to understand. So of course we have to work within those local standards. And good daylight design is not only a must for workspace, but something that improves architecture in general. So that's everything we covered today. I don't know if there's any questions from the
I tried to answer those I have spotted, so I hope we haven't forgotten any.
And I guess the most asked question out there is VELUX Daylight Visualizer really free and easy to download from the website?
It is very free and should be easy enough. We only ask for email and very basic information.
And you personally email everybody who downloads?
Then it becomes part of our newsletter, and then we can inform you when there's a new webinar or new tutorial and some new features in the tool. I mean, one of the questions I would like to maybe just discuss a bit. So somebody asked, you know, does it differentiate the value between 2 or 3 layer pane? It's very important to differentiate between what I say when I say layers of polygon is not the layer of glass in the pane, is really how you model the glass of the window, and in very old school radiance, like if you use Climate Studio as your daylight tool, then you really need to just have one single face, which is something Revit cannot even do as a primitive, right? So then you have an issue, or you need to account for it, because light will be transmitted again when it hit that first face and then the second one. But in Daylight Visualizer, we have either you want just a surface glass, it's just that one face, or you have the solid one where there's a certain spacing and then light goes through a polygon and then a second one. And you would use that whether it's a single pane window, a double pane, or a triple layer pane. Because a triple layer pane, if you're in a very detailed, you know, BIM object, then it could be layered with 6 layers of polygon. And then you would transmit the light way too many times. So that's what you need to be aware of and control for sure. There was another question about glare, and glare is not part of the metrics that Daylight Visualizer do. Yeah.
Perfect. And there's also a question for me. So that's about the BIMX workflow. So after saving the plans from VELUX Daylight Visualizer, you have these simulated plans. So you save them as a PNG file, for example. And that image you just pull directly into the layout. So we make a layout which has the plan drawing for the ground floor. And that's important for BIMX to understand where to put this image from the simulation. And then we just put the simulation image exactly on top of the floor plan in the exact right place and scale it so it fits perfectly. And when we have this layout, we can navigate to it in BIMX and then just hit the small 3D button, that's the one with the house, and it will automatically show the layout on top of the floor in 3D. And when you're there, you can always move that around in the right height if you want to have this extra precise image. So it's pretty easy, and I think it's really important that we don't only have a one-directional export, that we bring data out from the BIM, but we also bring the documentation back to BIM so we have everything in the same place. So that's everything for today. Next week, Friday, May 29th, we have our last webinar, Holistic Thinking in Design and People Planet Model. And we try to look back on this whole process and kind of figure out what we gain for using BIM to take so many different variations into account. Both for the functional part of the geometry of the building, but also for materials, for climate impact, for the indoor climate and everything else. And again, you can find all this on the VELUX website. So you go to velux.com and project-development-guide, and you can download everything. Also the Archicad files, BIMX, and what else you need. So that's all we had for today. Thank you so much, Nicholas, for joining us here.
Thank you, Thomas.
I think there was a lot of information to process, not only compute, but also process for the rest of us. I hope everybody was eager to start playing around with daylight and bringing that into their design of the buildings. Thank you so much for staying with us for a whole hour, and I hope to see all of you next week for the very last webinar in this series. Thank you so much.
Thank you.
Have a nice day.
Cheers.